Okay. Raise your hand. We'll get there. We'll get there. Not at the beginning. Raise your hand if you can describe to me what it means for figures to be congruent. Tyler. Same. Okay, so like I said, there's going to be 5 different ways for us to prove triangles are congruent to each other. Okay, the first is what we call side angle side. SAS. Okay, side angle side. And we're going to write SAS. Okay. So what this means, if we have 2 sides and an included angle of one triangle are congruent to 2 sides and an included angle of another triangle, then we have congruent triangles. Okay. So what I want you to notice about this picture, do you notice how the angle is in between the 2 sides?
Yeah.
So I can say side, angle, side. Side, angle, side. Yeah. We have 2 sides and an angle in between. Okay, so let's draw a picture to help us. Okay. Draw this triangle. Okay, so if I have 2 pairs of sides that are congruent, which angle would need to be congruent in order for this to be side angle side? Come point it out. Is she correct? She pointed at each. Okay. Okay, this is our included angle. We have side. Now, how often am I just going to say these are all congruent? Right? Yeah, probably not very often. What? That's where we're going to get to on Friday. But yes, these 2 triangles are congruent. So because we have side angle side congruent, then the whole triangle is congruent to the whole triangle over here. Yes, Tyler, that is correct. Okay. Right now, that's where we're going to stop. The triangles are congruent. Okay. So I'm going to draw a picture. I need you to draw it with me. Are you ready? Okay. Draw this, please. Do you need to go take a little walk?
No, but like.
Okay. Are these 2 triangles congruent?
Yes.
I don't see an angle.
Hold on.
Hold on.
Don't even need those lines.
Okay, so I'm hearing that these 2 angles are vertical angles, which means they are congruent. So these two triangles are congruent by side angle side. That's so great. So I'm just gonna make a little note to myself that these are vertical angles. Okay.
No. I know. It looks like it's coming in.
Just draw one triangle that's like.
Just, it's okay if it's not perfect. Of course it is. Of course it is. Okay. All right, Zach, what do you think about these two triangles? I asked him. Why, Zach? Okay, so like if I called this A, B, C, D, I could say that BC is congruent to BC. What do we call that? Ah, reflexive. So these two are congruent by side angle side.
Obviously, we know BC is congruent to BC.
Right. But it's not marked in my picture. So if I'm writing a proof that these two are congruent, I'm going to need to write, since it's not given, I'm going to need to write BC is congruent to BC because of the reflexive property. Okay. Oh, don't draw that. Okay, go ahead and draw these two. This is example number 3. This is our last one on this page that we'll turn. Are these two triangles congruent?
Yes. Wait, no.
Yes, they are.
Yes.
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 Yes, have the other
Two
angle.
sides.
It's included angle of side. Side angle.
Guess what? We don't have a side angle theorem. There are no bad words in math class. Angle side is not a thing.
Do you know that word is actually a donkey? Wait, what? I don't know.
Okay,
I'm not wrong. No, that's literally what it says.
but it also is not an appropriate word to use if you are not talking about a donkey, right? Okay, so let's talk about why. Adri.
Couldn't the angle there be like the same?
We don't know. We don't know. So we would need to have these two angles congruent if we wanted side angle side. But since we have angle side, that's not enough information for us to prove triangles congruent. There are no donkeys. What, Dalton? Can you look at this? Uh-huh, and then think about if I wrote it the other way.
Oh.
Okay.
Wait, you did
Okay. There are no donkeys. There are no cuss words in math class. No angle side.
Donkeys are colorless.
Okay, next page, let's write a proof.
Yeah, so far, some donkeys.
Code word, donkey. Probably not. All right. So let's just talk about this picture. We know that BD is perpendicular to AC. And so you see that they have a little 90-degree angle here. Okay. Which means what? That's good to know. All right. They've also told us that AD is congruent to CD. Okay, so notice how they share a side. So if they share a side, it's going to be congruent to itself. Do we have enough information? Okay, so let's get there. Okay, we can see in our picture, yeah, these are going to be congruent by side angle side. We just need to get all the information out. So let's go ahead and we always start with the given. So BD is perpendicular to AC and AD is congruent to CD. People, our given information, this guy right here is already a congruent side. We have one of our three pieces already given to us.
So wait,
What?
we're just solving, we're solving, see if these are congruent, these triangles. That's what we're just doing.
Yep.
That's why it says two.
Okay, now because BD and AC are perpendicular, what does that mean? Raise your hands.
That's how you that there anything.
So the measure of angle BDA equals 90 degrees, and the measure of angle CDA equals 90 degrees. Is that what you're telling me? How do we know that?
Because the right, the reflex of the block.
How about the definition of perpendicular?
Oh, yeah.
Yeah?
Oh, I didn't know we were asking for like that. That's CBD or CBA.
It says BDA and BDC, obviously.
Yeah.
We have to actually write it.
Well, it's also.
Because they said that we're perpendicular, we know these are 90-degree angles. Okay?
It's on a line. Yeah.
Yeah, we're getting there. Okay, so some people are just like ready to be done with the proof. I get that. You literally need two statements that saying as a side is congruent to a side, and one statement where an angle is congruent to an angle. I don't have an angle congruent to an angle in my proof yet.
BDA is.
Wait, I actually might.
So let's go ahead and say that the measure of angle BDA equals the measure of angle BDC. We got to get there first. And what did we use to get there? Transitive, or if you said substitution, then we can say that they're congruent. Okay, and so now we have an angle. Wow, you guys are so excited for this next one. BD is congruent to BD. We got to write it. We have to have all three statements, side, angle, side, in our proof. Notice how I've labeled them, so I know that I have them. Now, they happen to be in the order of SAS. It's okay if they are not, okay? But because I have side, angle, side, congruency statements, I can say that triangle ABD is congruent to triangle CBD because of side, angle, side. Write that one down. Why are you whining? Did you? You have a pocket in your sweatshirt that you want. No, it's, oh,
This
ew,
isn't
weird.
fuzzy.
It is fuzzy. I do see that. Honestly, this is probably one of the longer proofs we'll do.
So SAS, you can just put SAS as a reason.
Yep,
Wait, that's a reason?
yep. It's a theorem, side angle side theorem. Do you want to write it all out? Side angle side theorem? Or do you want to just write SAS? SAS sounds good to me. All right, so I want you to look at number 2. So we're looking at J N K congruent to M N L. So these two triangles are what we're trying to prove congruent. Okay. Our given information is that JN is congruent to MN and NK is congruent to NL. What have they given us?
Not everything.
Not everything. They gave us 2 side congruency statements. Where does the angle need to be?
In the middle.
In between the 2 sides.
Vertical.
Okay, so Keegan is saying, hey, we have vertical angles. Is that in the right spot? These angles right here are vertical. Are those the angles that we need for SAS? Yeah, they are. So we can say angle J and K is congruent to angle M and L because they're vertical angles. You guys, that's it.
Wait, we're
Fun, fun.
done.
No, we're not done, but we have all the information we need to say triangle J and K is congruent to triangle M and L because of SAS. Side angle side congruency theorem. Cohen, what are you doing? You guys, this isn't terrible. Not terrible. All right. Okay, let's go to the quilt. Okay. We know that PS is parallel to QR and that PS is congruent to QR. So PS and QR are congruent and they're parallel. Go ahead and write the first reason and statement there. None of this matters. It's just those 2 triangles right there. Okay, have they given us anything? Have they given us a side or an angle congruent statement? They gave us a side, okay? And an angle. any ideas about the angle? Layla, you have an idea? Ooh, we have parallel lines. Parallel line, transversal, parallel line. We know that angle S P R is congruent to angle Q R P. These guys right here. What kind of angles are those? Alternate interior angles are congruent. That gave us an angle. What about my second side? I need side angle side. Okay. Rhett, is there something we could say about a side congruent to a side?
ER is like reflexive.
Yes. ER is congruent to PR. Now, I do need to stop ourselves though. When I look at this statement, our PR is PR corresponding to PR. PR corresponds to RP. So what would that be?
Symmetrical.
Symmetric. Just symmetric. It's like everything we learned has been forgotten. 9 times out of 10, you need the reflexive. Okay. 9 times out of 10. Now, do we have side angle side? You betcha. Triangle PQR is congruent to triangle RSP because of side angle side. Or the side angle side.
That's right now. It's too easy.
Okay, go to 5-5.
I didn't get it down.
You didn't get it done? Okay, when you get it done, then turn to 5-5. 5-5. 1, 2, skip a few.
Wait, what are we doing?
145. Dawn, can you see this okay? You can't see it? What do you need me to, do you need me to zoom in? Is red not a good color? What is a bad color?
Green.
Okay, well, I don't usually do black or white, so that's good. Okay. Okay, so let's go ahead and talk about side congruence. So SSS, if 3 sides of one triangle are congruent to 3 sides of another triangle, our triangles are congruent.
How was we doing side?
Okay, so literally, if all 3 sides are congruent to all 3 sides, your 2 triangles are congruent. Same triangle, same shape, same size. Okay? So here, side, side, side. Side, side, side. Is that okay? All right. What are you confused about, Troy? Did you say you're confused?
Wait, I'm
I'm just
just trying
trying
to
to process it.
Wait, is there such thing as a
Going label?
That'd just be the same.
That would just be the same thing.
Yeah.
Ah, good call. Here's an equilateral triangle where all the angles are 60. Here's an equilateral triangle where all the angles are 60. Are they congruent? No, but they are similar. You'll be ready for next semester. Okay. Okay, so can I say that these two triangles are congruent?
Yes, you can.
Hold on. Layla, what do you have to say? Okay, so we have the reflexive property right here, right? So yeah, we have side, side, side. I know, right?
Isn't it always gonna be?
If you have all three sides congruent. Oh, what do you mean, like this guy? Oh, yeah. Yeah. But it's not all the time that our triangles are gonna share a side. But when our triangles share a side, we're gonna have to use that reflexive property. Okay. All right, now, real quick, I want you to come up here. We're gonna draw a right triangle. How do I know where the hypotenuse is?
Yeah.
Longest one, it's across from the,
It's across from the 90 degree angle.
okay, it is across from the 90-degree angle, and it's the longest side. Okay? Only a right triangle has a hypotenuse. The other sides are called legs. Okay? Now, we have a congruent triangle theorem called hypotenuse leg. We'll talk about adjacent and all of that stuff next semester. Okay, hypotenuse leg, HL. Hypotenuse leg, HL. If the hypotenuse and leg of a right triangle are congruent to the hypotenuse and leg of another right triangle, then the two triangles are congruent. So, number one, what kind of triangle does it have to be? Right. So we still need three statements. We need that it's a right triangle, and then we need two side congruency statements. Okay? Where one's a leg and one's a hypotenuse. In your proof, you need some fact about it being a right triangle. You need that two legs are congruent. You need that two hypotenuses are congruent. Then you can say our triangles are congruent. So this is what I would like you to do. Turn the page. I am going to give you 3 minutes. I am going to give you 3 minutes to decide whether these congruency trait statements are true or false and why. So your reasoning might be side, 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 or your reasoning might be not enough info. You and your elbow partner work together.
I think they're all yes.
What?
No, would this one be side the first one because it has two?
Yes.
I'm gonna change this to 1 minute. I bet you got one wrong.
Is it SSF?
Aiden.
Where? We can assume that because it's the same line. They can. If it's the same line. Yeah. Yeah. All right. Eyes up here. RO. Is this true? Yeah. Side, side, side. Okay. So, yeah. Cohen, is this one true?
Not enough.
Why?
Because it only has two sides.
But isn't HK congruent to HK?
We don't know that though.
Yes, you do.
If we know that automatically.
Oh.
We have to actually write it down. And so we record that we know that these are the same.
I'd rather play it safe. It doesn't have the three lines. How is it side to side?
Okay, I need everybody to shut their mouth. Cohen is not the only one who is confused about this. Is HK and HK are the same segment. Do you agree?
Yes.
Which means they're going to be the same length because they're the same segment. So we know that this segment, since it is shared by both triangles, it's the same length on both triangles. We can say that the third side is congruent. We know that. So these triangles are congruent.
I know, but think, if you have a right triangle and you.
This is not right.
If you measure it perfectly and it says 90 degrees on a measurement device, but it doesn't have a box, you can't assume. Isn't that the exact same thing?
It is not the same thing because this is literally the same segment.
Why wouldn't they just put the line? Yeah, why wouldn't they just put the line?
Because you need to
Oh my
know
God.
that since they're the same line, they have the same. I really dislike when you interrupt me when I'm talking.
I was the one like asking.
And I was answering your question and then interrupting me. So I'm going to go ahead and move on. How many of you put yes? How many of you put no? Why is it no?
It's not like UV is congruent to YX and it should be YX.
Okay, so like VW and YZ. VW and YZ. I don't think those two are congruent. Wah, wah, wah. Now, we do know that triangle UVW is congruent to triangle YXZ by side, 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 right?
Actually, I'm the one that came. I bet you were.
Okay. But that's really rude for you to throw that out.
What?
Like, if you don't know what I'm talking about, then know about it. What?
It's like the same thing.
It's not the same thing. You have to have the corresponding parts corresponding.
No, because it all. It's the same thing whether you write it different or not. It basically is.
Yeah.
It doesn't change.
Are these two congruent?
Yes.
Okay, cool. All right, so let's come over here to number 6. This is how we're gonna finish our day. B is the midpoint of CD. AB is congruent to EB. And angle C and angle D are right. If you wanna just like circle it and draw an arrow to save you some time, you will never do that on a test or quiz or assignment.
And then we have to rewrite it.
It has to be written down and like, just how it writes.
Cause these are formal, okay? They're formal. Did we figure anything out? Okay, well, we have this guy right here. It is not SAS.
No, it's the hypotenuse, HL.
Oh, yeah, if they're 90.
Okay, so we know that the hypotenuses are congruent because of this statement right here. We know that angle ABC and angle EBD are right triangles. Because the definition of a right triangle is that it has a right angle. These triangles are right triangles. You have to have a statement that says it's a right triangle. Okay? What does our next statement have to be? If B is the midpoint of CD, then BC is congruent to BD because the definition of a midpoint. And there's our leg. You have a worksheet. This is homework. It's homework. Anybody like wanted to help me? You don't need homework? That's false.
Buddy.
Yep.
Can I please?